Hello students, the question is, two particles of equal mass m have respective initial velocities u I cap and u I cap plus j cap divided by 2. They collide completely inelastically. The energy lost in this process is. Okay. There is a typical sum for perfectly inelastic collision. There is also a shortcut formula, but remember that shortcut formula is applicable only when the collision is rectilinear, that is along same dimension. But here see, the velocity of the first body is u I cap, that is along x-axis. So m is moving with velocity u I cap along x-axis, and the velocity of the second mass is not along x-axis, not along y-axis, but like this. It is u I cap plus j cap divided by 2. So this is not 1D collision, right? Therefore we have to actually calculate the final velocities of each masses. Okay, I hope you understand. And it is also given that they collide completely inelastically, and we know in perfectly inelastic collision the two bodies actually move along each other, not along each other, move with each other. That means they stick together, right? Therefore this situation is before the collision, and after the collision the two masses should move like somewhat this, suppose with velocity v, and the component of this v along x-axis suppose is v1, and component of the velocity along y-axis is v2, right? Okay, now I will write the equation for conservation of linear momentum from the principle of COLM, conservation of linear momentum. Okay, initial linear momentum along x-axis, or I can write the vector form actually. So let's write the vector form directly. So m into u I cap plus m into u I plus j divided by 2. This is the initial linear momentum of the system before the collision, is equal to final linear momentum of the system after the collision. The final linear momentum, we know the two bodies stick with each other, so the total mass is 2m into the component of velocity along x-axis is v1, so v1 I cap plus component of velocity along y-axis is v2, v2 j cap, right? And if you look carefully, m will go and you'll get u I cap plus u by 2 I cap plus j cap equals to, see, equals to twice of v1 I cap plus twice of v2 j cap. And if we compare this thing, if we compare this, you will get 3u by 2 I cap plus u by 2 j cap equals to 2 v1 I cap plus 2 v2 j cap. Comparing, v1 is 3u by 4 and v2 is u by 4. Now I have to calculate the loss in kinetic energy. Let's find initial kinetic energy, initial total kinetic energy of the system of the two masses before collision. It's very simple, half into m into u square plus half into m into, now see, it is given in vector form. It is also given in vector form, but its magnitude is simple u. It is given in vector form, therefore I have to calculate its magnitude. The magnitude of this thing is nothing but u by 2 into root over of 1 square plus 1 square. That is u by root 2, right? U by root 2. So half m u by root 2 square. Now final kinetic energy of the system after collision. See, the final component of x component of the final velocity is 3u by 4 and y component of the final velocity is u by 4. Total mass of the body is 2m. Therefore, resultant velocity will be along this, and the magnitude of that velocity is nothing but root over of u by 4 square plus 3u by 4 square, which is root over of 10u square by 16, right student? Root over of 10u square by 16. Therefore final kinetic energy half into total mass 2m into velocity square, that is 10u square by 16 square, which will give you m into 10u square by 16, that is 5mu square by 8. And if you add these two things, you will get half mu square 3 by 2, right? We have to find, look at the question, the energy lost in this process. The energy lost in this process is initial kinetic energy minus final kinetic energy. So loss in kinetic energy is initial kinetic energy is 3 by 4 mu square minus final kinetic energy 5 by 8 mu square, which is nothing but mu square divided by 8. So correct option is option D. Thank you for watching this video. Please subscribe my channel, Phi Solver.